I think the best place to start is just talking about the core technology driver, which is photolithography at this point. So what photolithography entails is putting a layer of photoresist on a wafer and then exposing light onto the wafer, exposing a pattern using light onto the wafer, and then developing what's been exposed, and then etching away material that you don't want, keeping material that you do want, and then using that foundation to build the structures that you need, whether you have conductors or spaces that do not conduct. That is at the core of the technology. So that photolithography process is the main thing. So the wafers come into the factory bare.
Okay.
They have a mirror finish. There's no pattern on there at all. And then 3 months later, they come out of the factory fully patterned with the grid pattern that you see, and sent overseas and sliced into the die that make up the working part of a computer chip. That whole process is maybe 1,500 steps, and those steps at the heart have this photo layer and some of the metal layers and those structures to build the wafer. Right now we have over 60 photo layers in our process. So that whole module, all the steps of laying those films down and even taking the measurements is repeated over 60 times. So the light, it's like a photograph. So you have a photosensitive chemical on the wafer, and the light exposes, we shine a light through a piece of glass that has lines drawn on it in chrome, and the light goes through where there are not lines onto the wafer, and that pattern is exposed onto the wafer. And then that wafer with the exposed pattern is sent through a developer, basically. And you develop the parts that were exposed by light, and the parts that were not, you clean off, and those are the lines that make up the foundation of the circuitry in the computer chip. Once the lot is introduced into the system, it's on a flow. It has a flow already, these 1,500 steps or more. And that flow is driven by the process that product is on. And we have a factory system solution, a piece of software. The generic term is MES, Manufacturing Execution System. Other industries, many industries have an MES, and it's essentially a inventory management system. The MES tracks what product is at what step on what flow. So that's kind of the master. And as a lot goes to, well, let's say it's introduced in the sorter, and it's introduced in the factory, it's going to ask, where's the first place I go? And the MES will look up what lot is it, what recipe, or what flow is it on, and what tools can support that step, and what tools have the recipe for the step that product's on. It'll make a decision. That decision's handed down to the automated material handling system. It'll dispatch a vehicle, which will come to the wafer sorter and pick up the FOUP and take it to that first step. And then you do that over and over again 1,500 times until it comes out of the factory at the end. People try to improve things. So if we are running up into a boundary in terms of either process technology or more of this operational industrial engineering that we've been talking about in the last few minutes, the people are there to understand the behavior of the factory, understand where the challenges are, and try new things. And that's why we have this Manufacturing Technology Development Center. We can try new things here, and if they don't work, if something breaks, it's not an issue for our factory or for our customers. So we might try a new robot, we might try a new software solution, trying to speed up the process or improve the decisions that are made, where to send the vehicles, or how to move the wafers inside the tool. We can adjust all those things, and you're always trying to strike a balance between safety and performance, and you want to push, right? But at some point, as you're pushing, you're going to slip, right? And this lab is all about finding those boundary conditions and understanding how far you can go and still be safe. And then once you do go over the limit, how to recover. That's just as important.